experiment aims to demonstrate the process of osmosis by observing water movement across a semi-permeable membrane into a region of higher solute concentration. Materials required for this experiment are a large potato, sucrose or sugar syrup, 2 pins, a bowl or a container, and water. Peel the potato and cut it into a cube-like shape. Then carefully carve out a rectangular cavity in the center of the potato. The cavity should be large enough to hold a small amount of liquid. Fill the bowl with water and add red color to it. This is optional, but adding color will enhance the clarity of the demonstration and will help us visually track the movement of water during osmosis. This water will serve as a hypotonic solution, which means a solution with lower solute concentration. Place the potato cube in the bowl of water and carefully fill the carved cavity in the potato with sugar solution. Here, sugar solution acts as a hypertonic solution, which means a solution with higher solute concentration. Avoid mixing the sugar solution with the water in the bowl. Mark the initial water level inside the potato cavity with a pen or by pushing a pin through the potato wall just above the water line. Leave the potato setup undisturbed for around 20 to 30 minutes and observe any changes in the water level inside the potato cavity. After 30 minutes, again mark the water level inside the potato cavity. We can see that there is an increase in the water level inside the potato cavity compared to the initial level. Also, we observe that the liquid color inside the cavity has slightly changed. This means that the water from outside passes through the potato walls, which acts as a semi-permeable membrane through osmosis. This experiment aims to demonstrate the concept of density by observing how different liquids with varying densities form distinct layers when placed together. To perform this experiment, we require a transparent container or a glass, water, honey, oil, and washing liquid. First, add some water to our container. Carefully pour vegetable oil on top of the water. Now, watch closely as I carefully add another liquid. See how the oil forms a distinct layer on top of the water? This is because oil has a lower density than water. It looks like two separate liquids. Now, slowly add honey to the container and observe what happens. The honey sinks all the way down, forming a layer below the oil and water. Honey is much denser than both oil and water, so it sinks to the bottom. Let's see what happens with washing liquid. It forms a layer below oil and water and above honey. This means that its density is greater than oil and water but is less dense than honey. This experiment demonstrates the relative densities of water, oil, honey, and washing liquid. Liquids with lower density float on top, while those with higher density sink below. Here, oil has the least density, followed by water, washing liquid, and honey. Honey has the highest density of the four liquids. Combustion is a chemical reaction between a fuel and oxygen that releases heat and light. In this experiment, we will demonstrate that oxygen is essential for combustion by observing a candle's flame under different oxygen conditions. To perform this experiment, we need a candle, matchbox or lighter, and a glass jar with metal lid. Place the candle in the jar. Light the candle. Observe that the flame burns brightly as it is getting sufficient supply of oxygen which is present in the air. Now restrict the supply of oxygen by covering the jar with a metal lid or plate. The flame goes out because combustion requires oxygen. When the jar is covered, the candle can no longer access enough oxygen from the enclosed air to sustain the burning process. Hence, this experiment demonstrates that oxygen, a key component of air, is essential for combustion.